All right, in my opinion, this is one of the hardest questions on the practice test. There's just a whole lot to it. So cosecant is 1 over sine. Do you agree? All right. So it says the cosecant of some angle that we don't know is negative 1.124. Well, you won't find cosecant anywhere on this computer. So you got to think of that as 1 divided by the sine of theta is negative 1.124. Do you see what I did there? I changed cosecant into 1 over sine. Now, what I'll do now is I'm just going to make that a fraction because I'm allowed to divide anything I want by 1. Now remember, if 3/4 equals 6/8, then doesn't 4/3 equal 8/6? Yeah, you agree? Okay, so look, I'm going to get rid of that real quick. So that's kind of like a little thought experiment where I solve a simpler problem to make sure that is a legal step. And now that I'm convinced that that is a legal step, my next thing is to flip these. So sine of theta over 1, I don't need that, is is 1. I'll just 1 on top over negative 1.124. Okay? All right, now, so we know sine is negative. Where is sine negative? Is it negative here? No, it's positive. Okay, remember, we're looking at the opposite, the y value. That's right. It's positive here, it's negative here, and it's negative here. So here's what we got going on. We've got a triangle here and the exact same triangle over here. Okay? This is negative 1. In theory, the radius or the hypotenuse is never negative. That's why I put the negative with the side. And we want to know this angle. How do you get rid of sine? It's sine inverse. So if I take the sine inverse of both sides, that's going to tell me what theta is. Now, since I'm working with you and I know you well, and I know most kids prefer to think in degrees, I'm going to start this in degrees and then translate my answer into radians. You don't have to do that. You could just find it in radians, but for a lot of people, it's a jump too far, okay? So I'm going to change into degrees. And then I'm going to go second. Here, quick. All right, second sine. So sine inverse of 1 divided by negative 1.24. Thank you. All right, so look, that makes sense, right? This angle is negative 62.83. See, the problem is they want it between 0 and 360. So now I need to tap into this reference angle thing. So go back to the picture. That angle is also 62.83. So answer my questions very carefully here, Audrey. Okay, how far is it to get, how many degrees did I just rotate? 180. Now, we got to go 62.83 more. So I'm going to do 180 plus 62.83. All right. No. So it's 242.83. I can do that. this calculator doesn't work very well. All right, so my first answer is 200. Come on now. 242.83. Okay. Now, to find this one, Aubrey, the easiest way I can tell you is just subtract it from 360, right? And that'll give me the positive version. So 360 minus 62. God, why won't it take the 6? 6. And you get 297.17. So we got 242. Jeez, with Pete's. This is almost impossible to work on this. 0.83. And you got 297.17. Okay. The last thing to do is take these. Oh, come on. And change them into radians. So here we go. 242. Well, I already have that one. Times pi divided by 180. 5.18 radians. That's one of them. 19 radians. What's that? Nope, we can't write those because it was a weird beginning, so it's going to be a weird ending. Okay. The other one we got to do 242.832. 42.83. This is just driving me insane. Times 180 divided by pi. Okay. 242.83. I missed a parentheses there. Sorry, times pi is what I meant to say. Now I'm getting all frustrated. Now it's not working there. I think I'm done making these videos on this one. Can you do this for me on your calculator, Aubrey? And you got 4.2. And I really do think that might be the hardest question on that practice test. It seems like it's innocent. It's so short, but that's so many steps. So what did we do? I drew a picture. I changed it to sine. And I drew a picture so I could figure out what the opposite and the hypotenuse was. Then I found my reference angle. That's called my reference angle. Well, then I had to find some that were in my range that they wanted. So then I found them in the proper range. Then I converted them into radians.